All right, in this series of videos, we're really focusing on trying to learn the basics and make sure we know the basics of C#. In the previous video, we did something incredibly simple. We created a very basic console application. We're now going to extend that. And one of the first things I would normally cover is like how to assign things to variables. We're already doing that a little bit here. We have this var name. We ask this question, what is your name? And then we come in here and we do a console.read line. That's going to read a single line from the console, from that little window that's going to pop up. And we're going to enter our name, and then it's going to display it back to us. Let's try this. Now, sometimes it may take a few seconds for things to build and run. Sometimes they're going to be almost immediate. I'm using Visual Studio running on a VM, on a virtual machine, running in the cloud. So things probably aren't going to be as fast as they could be if you're running on your machine. One thing nice about .NET is you can run it on a variety of platforms. You can run it on Mac, Windows, Linux. This example, I'm using Visual Studio on Windows, which is probably the best platform for doing .NET development. I personally do most of my development for .NET using Writer on a Mac, and it's actually a really great experience as well. We'd have this, it pops up a little line here. It says, what is your name? It does that because of this line here in our program, console.writeLine, what is your name? Hence there, I'm going to type in Chad, press enter. Oops, I accidentally put a little quote there and said hello Chad with that quote. Put the little quote there because I'm not a wonderful typer. And we get that. And that's what this little bit of code does here. Now, there's a few interesting little nuggets here, but one of the first ones I want to cover that I think is fairly important is this notion of top-level methods or functions or statements. Here, top-level kind of statements. These are running without a main. Up until I think it was like around C#10, this wasn't possible. This is a new thing that's been added to C#. And I do think it's something you're not going to run into a lot, but if you are doing this, it's going to be like something fairly new. Most C# programs created today are probably being created this way, where we are using a top-level statements. This could have been rewritten, and up until probably C#10 or something, it would have looked like this. We would have created a class for our program. The name of that was completely arbitrary. Everybody used program though. And we would have had a static void main, a static main method that would have passed data into our program. These two are equivalent. I actually can't run this. If I try to build this and run this right now, it's going to give me an error. And anytime you see an error, it's going to say there are build errors. Would you like to continue and run the last successful build? Always say no. We want to look at those errors. We almost never want to run something, especially when there's build problems. We're just walking into a bad thing. Let's get things running first. We can't have two mains is effectively the problem. Or we could, but it won't have to be marked as partial. We shouldn't do that. I can fix this by commenting that out. Now, notice I did a quick block comment there. All editors, or almost all editors, support some notion of this. In this case, this is equivalent to going to Edit, Advanced, and toggle line comment. That's effectively what I did, line comment there, not block. I don't know why I said block, but line comment. Boom, and I put it back. I did that using a keyboard shortcut. It's good to know keyboard shortcuts, but you can use that up there as well. Again, you're going to get something like this in almost every editor. Now if I run, what is your name? I can do it again. Get hello Chad, and we're done. All right. And we can put this back. And if we do that, we can't have this. So I'm going to delete that. And we can run it again. There's your name. And it'll give us something back. That's the notion of top-level statements. It's not, again, something we're going to run into a lot, but I wanted you to be aware of it. It could affect how things are running, especially if you're running some older code. It's very important to know. It's a good start, though. All right, we'll jump into the next video. We're going to get into variables. All right, we're back. We're going to jump in and look at variables now. And we have a variable already here. We have this var name. Var is a keyword. It was added probably around 2008. So it's been around quite a while. It can mean effectively anything. People think that means things are not typed. They are. C# in general is a statically typed language. That means all types are defined by the developer writing them in the editor. There are ways to work around that in C#, but in general, C# really wants to be statically typed. Static typing, some people refer to as the first unit test. It ensures all our things will build. It's, in general, pretty nice. I think that one of the bigger reasons for it, though, it actually helps tooling a lot. Because our editor can know the type of something, it can provide us better autocompletion for that. Now, with the notion of AI-assisted programming, things like GitHub Copilot, I don't know if types are as big of a deal as they were 3 years ago or 5 years ago. Right now, I still think they're valuable, but we'll see where we're at 10 years from now if we still see types as valuable. But anyways, we have this variable here, and we have it's named name. And if I F12, it says navigate to definition, and it navigates us to type string. That is because this is a string. We could have written this string here. That would have been equivalent. Now, if we do an integer here, it will yell at us. It puts this red here because that is not assignable to an integer. If you put a var here, it will take whatever thing there and work. You'll get different philosophies on whether it should be typed or not typed. I think some people will make a strong case that everything should be typed and it makes it easier to read, easier to do code reviews on. I'm personally not a fan. I'm personally a fan of var everywhere. I think types are really useful. I think they're more useful for the editor than they are for us. I think we can often infer them and do a pretty good job inferring them. So I don't think they're of much value. Now, if you come from other languages, such as TypeScript, you may think of different things. If you're in a JavaScript world, var means something slightly different because in there, typically, if you're in a TypeScript world, you want to use let and const. You typically don't want to use var in JavaScript, but in C#, I think using var is a good idea. Now, one thing I do want to point out with variables and kind of play along here is I don't love us defining the variable really before we need it. We could have defined it here. In general, in programming, people recommend defining things at the latest point you need it, and I think that is in general good advice. So we can define this here, and we can run it, and it will behave the same. We'll get hello chat. Now, with variables, they do kind of have implicit type. Var age equals console dot readline, and we can now get our age. Now, the problem with asking for age, and we'll find that out here in a second. What is your age? We'll put that in. And then, actually, I'm going to put this up here, and then we do console, your age is this. So let's run this and see what happens. What's your name? Chad. What is your age? 47. You're 47 years old. That's interesting. And it all worked and seemed to work great, and the world's all wonderful. We were able to drop that in there and show it. What's the problem? Well, we typically don't want, or we wouldn't want to store age as a string, and that is what this is returning. So if I F12 here, it's a string. We'd probably want that to be a number, right? And there's a variety of ways we can get this to be a number. All of them have different trade-offs. I'm going to choose a fairly easy one right now. Maybe not the best one, but we're going to choose one. It's giving us a little warning there. It could be null. We're not going to worry about that. We can actually have other problems. Actually, int.parse. Now if I F12 this, I did want to show this. It's now going to give us an int. So it's now an integer. So let's run this and see what happens. What is your name? Chad. What is your age? Let's do 47. You're 47 years old. Now it appears that everything worked just the same, but now we actually have age as a number. So now we could do console dot right line, you are I don't want to get into that. That's showing you are, and we're going to do age times 7 in dog years. If we had left that as a string, we couldn't have done that. Now, if we're in the JavaScript language, we maybe could have done some stuff there and it would have gave us an answer, but not a good one. But because we have this as an integer, we can actually do this. Let's see how old I am in dog years. So we're going to run this again. And I'm 329 years old in dog years. Getting up there if I was a dog. So that's, interesting. It's a number. We can do things with it. We have those number-related things we, could do. Also, though, that int.parse could be a problem for us, right? It's assuming it's an integer. There's name, Chad. Almost anything can be a string, but what happens if I say my age is... Type it out. Is it going to work? Boom. No. Because that input string was not the correct format for an integer, it's going to blow up. And it's going to get a system.format exception. Now, a system format exception, you're going to run into those, but this is because we're doing a parse. And this is going to do a hard insert into that. Now, we could have done something, and we're going to play with some variables to kind of work around this problem. And we're going to give an error to the user. There's a variety of ways we could have done this. One is we could have put everything inside of a try catch. Let's see what happens now. What is your name? Chad. Old you. 47. And it blew up and it says, please enter a valid number. What happened? Well, because this wasn't a string, it threw an exception, but that exception was now caught by this try catch. Try catches are kind of advanced, but I wanted to show this here. You know, you're going to run into them. It's important to know how to do this. And again, I want you playing along, kind of building effectively the same application I'm building here. Now, for this next piece, we are going to go through and get rid of this try catch. Try catch is a way to solve this problem. In general, I think we're best to avoid using exception handling in our programs as much as we can. We're going to have to do it a few places, but let's keep it to a few places. So I want us to try, and we're going to do we're going to read the age as a string, and then we're going to try and then parse it. So how are we going to do that? Be thinking about this. Maybe even pause the video. How are you going to parse that? All right, we're going to throw it into age str and parse it. Now this isn't going to be wonderful because it's going to do the exact same thing. So what are we going to do here? Let's try it and see what happens. Well, we know it's not going to do the same, so I guess I don't feel like I need to try it. We need to look at parsing this in a different way. There's two ways we could do this that I can think of really easily, but I really quick want to show int dot try parse. Actually, this actually we can just do an int, and we do this method try parse, and it'll output the result in an age variable. This out statement here is something we will get into during the course of some of these videos, not the immediate ones, but it's an important concept. It's an output parameter to this method. It's going to actually output the variable that's coming in. By default, things are passed by value. And this one we're choosing to pass with this out, so it's going to be outputted on the result. So just right now, be thinking we're going to actually update that variable. That's what that out is meaning for us. Now we can do this. Let's run and see what happens for us. What is your name? What is your age? 47. That worked just as before. Let's run it one more time, but this time I want to type in Chad, and we'll just type Chad for my age. Doesn't make any sense. It says you are 0 years old, and you're 0 years in dog years. That's interesting. Why is that? Well, because try parse, kind of as the name states, is trying to parse it. Now, our goal isn't to get into control flow right now. We're going to do that in another video. But just be aware that this method is returning a Boolean, and we could be checking the status of that Boolean to see, is it returning the value we want? For right now, we're more focused on variables and just kind of getting a little bit assigned to how that kind of works. Now, for right now, we're going to live with this little bit of weird, but we are going to move on to, we're actually going to create, we're doing this math right here. I want to change this to be var dog years equals this, and then dog years. And why did I do that? Well, the other one is actually totally fine and totally acceptable, but I just want to show we can take an expression, age times 7, and store it in a variable dog years. And this age times 7 will result in an int because we are using ints. That all make sense? Hopefully it does. You can get and do this. Hopefully following along. Now, one of the things I wanted to look at, or at least bring up in some of the math related stuff, what if we divide by 7? What if we change our equation for dog years? Save this, run it. Change what a dog year is. Chad, we'll do 47, and you're 6 in dog years. Math becomes interesting. We start doing division with this, and we're storing it in an integer. The reason I say that is because it will fundamentally convert that and do some rounding there, right? Let's do this again. We still get 6 in dog years. We could make things into a decimal or a double and get a different value. I mean, we could actually get a better value, or I guess more accurate. What if we put double in front of age? What if we cast it to a double, a floating point number? We now get a floating point number as our result. We started with the floating point number, did division on it, and got a floating point number. That's at 6.7. Very important when anytime you're doing math, you must know what type of numbers you're working with. If you don't, it's going to be hard to know what type of results you're getting. Now that result, 6.7 and a bunch of stuff after, it's not wonderful. We maybe want to do some cleaning up if we were to display that. But at this point now we got more accuracy. And if I look at this var here and do an F12 on it, it's now smart enough to know we're going to a double. So again, even though var doesn't really change, it's the same word. If I get rid of this, we're going to have an integer. Now, for your assignment, is I want you to ask the person for their height in using a console read line. Ask someone for their height, and then take that height and just output it back to the console. That's all I want you to do for right now. Take in their height, output it to the console. All right? And then we'll jump into our next video. All right, we're back. Now we're going to talk conditionals, doing stuff like ifs and whatnot. Your original assignment, the one I just gave you, was to ask someone their height. How would we do that? Putting it in inches there, because to be quite honest, I wouldn't know what my height is in meters. Var height equals. Why doesn't it like that? Oh yeah, that's an interesting. Look at that. I kind of blended two lines of code together. This doesn't take. What is your height in inches? Really quick, this is just for my own sanity. I'm going to go back and change that to times 7. So let's run this and see if we're back. .47. Height in inches, 70. Okay. Now conditionals, we're going to jump in and kind of cover conditionals now, like typically seen as our if statements. I'm going to cover looping in a whole separate video, but we want to do some if statements in our code. And how do we do that? It's actually pretty straightforward. We typically are just going to use purely an if. If age is greater than, actually we'll go with that one. And we'll put this one up above. I like what this was putting in there. I don't know why I put the height in there. We're not going to do that. Now as the co-pilot, you could be over 21. You don't have to be 61 inches to be an adult. But if we run this, but actually adult typically, this is also one of the problems of using AI to do things, typically doesn't really know, it has weird rules and weird assumptions. So we're going to say if you're over 18 in the United States, if you're 18 or greater, typically seen as an adult. So we're going to come in here, there's your name Chad, 47, 70, and it says you are an adult, 70 inches. We're not doing anything with that inches. Real quick, I'm going to jump back and kind of talk about this one. This one's if some condition. Whatever's inside these brackets are the if, the true part of that condition. The else is if it's false. You're not an adult. If I change this to be less than or equal to that, that would be wrong. It's really common in code. It's really, really common to have these conditionals backwards. We typically don't want, or we typically, if we're having an error in our code, those sorts of things are some of the most common things we're going to get wrong. We're going to go back down to our height now. If height is greater than, we're going to go 6'7", which 6 foot would be 72, right? 72 would be taller than 6 feet. If we add 6 inches onto that, or 7 inches, that'd be 79. We're going to go, you're very tall, and if height is greater than, actually I like this one. And if height is greater than 59, your average height, I don't know if that's true. I assume, I guess I don't know what the average height is. We'll go with it, and then you are short. I think 60 inches, is 5 foot. we'll go, you are and if you are, we're not going to have an else condition this time. I'm just going to get rid of that. We don't have to have an else condition. You know, we have you are very tall if you're greater than 79 inches, which is pretty tall. That'd be 6'7". And if your height is greater than 60, you're taller than 5 feet. The reason I put the 60 or 79 in there is the average NBA player is 6'7". So if you're taller than 79, you're taller than the average NBA player. So let's run this. You notice we have some squiggles. So we get an error when we try to run it. Error again. So we got to fix that. Operation greater cannot be applied to string and int. So again, we have to do some conversion. So I'm going to take the lazy route right now and do int.parse and just parse that string. We could have done a try parse there, and maybe we should have, but we're just going to use an int.parse right now. And you're taller than 5 foot. So it kind of worked out. Now, this is, you know, again, we're using that int.parse. Could be a problem for us. Again, we're doing some basic math here with it, or just checking that it's greater than 79. We could do some math with height. We could do some other things as well. This is, again, pretty basic. We're getting a variable and doing some conditionals with it. We could string multiple conditionals together. Because this, you know, means, you know, you're taller than an NBA player, but maybe we just want a conditional if height is greater than 60, you're taller than 5'3". Again, Copilot Assist, not doing a great job there right now. But we'll do this. So, and just for the sake of speeding things along, I'm going to temporarily comment all these lines out just so I can not spend so much time in them. All right? So we have, what is your height? It's going to ask us our height. We're going to read that, and we're going to display that, and then we're going to display some stuff around that height. What is your height in inches? I'm going to do 70 inches. Yeah, that'll be okay. And it says you are 7 inches tall and you are taller than 5'3". So it hit this condition, right? Ooh. And very interestingly, and this is a slight mistake on my part, I wanted this to be else. I'm going to run it again. It's going to produce the exact same results as last time because I'm going to still enter 70. It says you're taller than 5'3", right there. All right. Now, what would happen if these were ordered differently? 70 inches enter the same thing. And then it also says I'm taller than 5 feet. Because how these if statements work is they're going to run one at a time, and the very first one that passes is the one that it'll hit. So even though this one would also be true, because this one was true, it ignored all the rest. So the first one that is true will win. And So just that's something to be aware of. And I want to point out some fun around Boolean logic, around conditionals. We have single things like this. We can also do and, right? Like this. And we can do ors. It's less than 60. We can do ors as well. And Boolean logic is a pretty big subject. I'm not going to get into this too much into this video. But let's try what happens right now if we throw 60 inches in there. Right, in inches, I'm going to do 60. And all it says was, you are 60 inches tall. It didn't hit. It didn't spit this out. Didn't print this, and it didn't print this. It's because none of the conditions were true. It's not taller than 79 inches, not taller than an NBA player. Height is not greater than 60. Height is not less than 60, because height is 60. Height is not greater than this one. And you'll notice that the height actually is less than 79. So why didn't it report on this one? It's because it's an and. It has to meet both conditions. It has to be greater than 63 and less than 79. And there. So that's why this one didn't report. But we could add an else condition. It's often, if you're having these sorts of things, we often want an else. And I'll just do right line. You're 5, 3 or shorter. I'm going to let that go in there. It's not super accurate. I'm just going to do else. And if I run this again, I enter, 60, it says else. It hit that else condition. So it's very important to be thinking how you want these things to behave with these conditionals. And you kind of have to get into Boolean logic. Probably worth maybe a video in and of itself just on Boolean logic. Play with these things. Very important. Very important to be able to look at them quickly and understand what's going to happen. Now, one other thing to be aware of is there's this tyranny operator, and then we can do stuff like if height is greater than 0, stuff like this. Now, you almost have to, by definition, be taller than 0, I think, but we can go with it. You're not taller than 0. And this is actually would be equivalent of this statement right here. Would be equivalent to if height is greater than 0, that would be equivalent to this here. Typically with this operator, we are trying to assign a value back to something. So you wouldn't, typically we'd be doing something like bar has height. Now, admittedly, this is kind of a silly thing to assign to because you could literally just do this, right? But I was just trying to show that operator there. Again, feel free to play with that operator. I think it's a good thing to know. You are going to see it in code, so you do need to know how to use it. Just trying to be just a little bit of an introduction here. So now I'm going to give you an opportunity to pause this video. I want you to get everything back in here and working. Once you convert this to a try parse, And I want you to add a condition to this that will display if you are taller than 7 foot. If you're taller than 7 foot, that is 84 inches. Add that to this so it will display if you are taller than 7 foot. Probably not taller than 7 foot. It's not a very high probability, not a large percentage of the population, but let's go ahead and put this in there. All right.